In this example, we're going to take another look at using L'Hopital's rule to compute limits. In this example, we have the limit as x goes to infinity of the natural log of x, quantity squared, divided by x. So what we want to do is to take a look and see what happens, or what the limit as x goes to infinity of the top is, and what the limit as x goes to infinity of the bottom function will be. And the bottom limit is clearly going to come out to be infinity. If we just took a look at the limit as x goes to infinity of the function x, as x goes to infinity, well, x goes to infinity. On the top, right, we know that the limit as x goes to infinity of the natural log function, right, is equal to infinity. That's one of the facts that we mentioned at the end of the first L'Hopital's rule video. And so now we would have that function squared, right? So the inside number here, ln x, is getting large as x goes to infinity. Well, when we square that quantity, then it's going to get even larger, right? So the limit of the top is also positive infinity. So we're in the situation where L'Hopital's rule applies. What we're going to do is take the derivative of the top, put it over the derivative of the bottom, and take that limit as x goes to infinity. So taking the derivative of the top involves the chain rule, right? The inside being natural log x, the outside being 2, or x squared, rather. So take the derivative of the outside, I would bring that 2 down and drop that power by 1, right? Which I just didn't write here. Then leave the inside part alone, so I'd leave that ln x alone there to the first power. Again, I didn't write it to the first power because anything to the first power, right, is just itself. And then the third step of the chain rule is to multiply by the derivative of the inside. Well, the inside is natural log of x, and its derivative is 1 over x. Next, I took the derivative of the bottom function. The bottom function is x, and its derivative is just 1 there. Okay, so I can simplify that a little bit as dividing by 1, right, is, I can just omit that. And then I have 2 ln x times 1 over x. That comes out to be 2 ln x over x. All right, next up, I want to analyze what's going on as x goes to infinity with the top and the bottom. And so the top is going to be infinity again because of the natural log, right? The limit as x goes to infinity of the natural log function is infinity. And of course, the bottom part, the limit as x goes to infinity of x is also infinity. All right, so I can apply L'Hopital's rule again because I have the infinity over infinity situation. The derivative of the top, right? I'm going to use the constant multiple rule. I have 2 times the natural log function. So the derivative of that would be 2 times the derivative of the natural log function, which is 1 over x. And the derivative of x on the bottom will be 1. So simplifying that out, I get the limit as x goes to infinity of 2 over x, right? That is going to wind up to be 0 here. Okay. And so therefore the original limit, right, the limit as x goes to infinity of the natural log of x squared over x also is 0 by L'Hopital's rule.